Now, got it? 1. In the diagram for the problem 1 here, if ZA is 9, so here the length of ZA is 9. What is the length of ZC? I need to find the length of ZC. Now, what is the relation between ZA and ZC?
ZA is 2/3 of ZC.
Bravo. ZA is 2/3 of ZC. So if the length of ZA is 9, I need to find the length of ZC. So you have to say 2/3 ZC. Then, in order to cancel 2/3, you have to multiply it by its reciprocal. So then, ZC will be 9 times 3 is 27/2, which is 13.5. So the length of ZC will be what? 13.5.
Yes. 13.5, yes.
Is it clear?
Yes,
Yes,
miss.
miss.
Okay.
Yes, miss.
Yes, teacher, it's clear.
Now for the medium, do you have any question?
No.
It is
No,
a line
miss.
starting from the vertex, ending with the midpoint of the side, of the opposite side. Okay. Now here, as you see, from its name, median, as I told you, from its name, median. So it's starting from the vertex, end with the midpoint. So median ending with the midpoint. So if I want to draw it now, I'm starting from the vertex, ending with the end point. And it's not perpendicular. Its job is starting from the vertex and cut the two sides into 2 equal lengths. Now, if the line is starting from, so here, if we have it like this is the vertex, come in the midpoint. As an example, like this. This is my triangle here. And then I will say this is my midpoint. Actually, this is my midpoint here. And the line that is starting from the vertex ending with the midpoint, we call it median. Now, if the line starting with a vertex and now stay with, focus with me here, starting from the vertex and perpendicular on the side, must be perpendicular. Starting from the vertex, perpendicular to the side, we call it altitude. So the first one, it couldn't be perpendicular. Maybe perpendicular, maybe not. But it must end with the midpoint of the opposite side. The altitude, no. The altitude starts from the vertex, but it must be perpendicular. Here, it's not perpendicular. Here, it's not perpendicular. Here, it's not perpendicular. They say, I am starting from the vertex, ending at the midpoint. Maybe I could be perpendicular, maybe no. But for the altitude, he said, I must start with the vertex and going on a perpendicular angle. I must didn't go to the right or to the left. I must be on a straight line until I reach the side of the triangle. If it is here, I will stop here. If it is here as an example, I will stop here. So this is the altitude. Now the median, as you said, as you see before, or as you saw before, sorry, it must be inside a triangle. It couldn't be outside, it must be inside. But the altitude, it could be inside or outside the triangle.
طب miss, these medians and attitude يعني are bisectors or only like medians and attitude?
No, they are not bisectors, only from their name. Only they are, I told you that we have 4 concurrent lines. Perpendicular bisector, angle bisector. For the third one, which is median, since it starts or its end with the midpoint, so it cut the line into 2 equal halves. So it bisects the line. Median, it starts from the midpoint up to the vertex. So it's cut the line into 2 equal halves. And it's cut the angle into 2 equal halves. But the angle doesn't matter to me. It's matter to me that this side is equal to this side, since it's starting from the midpoint, ending with the vertex. So it bisects the opposite side. Okay?
Okay.
Now let's talk about the altitude. The altitude is a perpendicular segment. So this is the first important thing. It must be perpendicular. It must be perpendicular segment. Now, from a vertex of a triangle to the line that's containing the opposite side. As an example, if this is my triangle here, if this is here my triangle, if I want to draw the median, I told you like, where's the midpoint? This is the midpoint. From its median, from its name, the median, it must be from the vertex ending with the midpoint. This is what the pink one, this is the median. I draw it from the vertex and I end at the midpoint. Now let's talk about the altitude. The altitude says, no, I am on a perpendicular segment. So when I come, I mustn't go to this side or to this side or up. No, I must be perpendicular. So I'm starting from the vertex, going down in perpendicular angle. When I face or when I meet my opposite side, I will stop here and make an perpendicular angle or 90 degree. This blue one, we call it altitude. So it must be perpendicular. Altitude. The midpoint, no. The midpoint is start from the vertex, but it's end at the midpoint. It's not perpendicular. This angle here is not 90 degree. So both of them are starting from the vertex, but the midpoint end, or the median end at the midpoint, but the altitude stop at a line at any point, but it must be perpendicular on that line. Is it clear?
Yes, miss.
Yes, teacher.
Okay. Now, the altitude of the triangle, as I told you, it could be outside or inside, or it could be a side of triangle. So it could be inside or outside or a side, and it could be on the same side of the triangle. Now, the lines that contain the altitudes of a triangle are, let's come back. Let's draw it here now. Let's say Bye-bye to the median. I don't want you now. I want only the altitude. Now let's draw for this angle, for this triangle, let's draw its altitude. I told you that it must start from the vertex. Now let's start from here and draw an angle of perpendicular side. Where is perpendicular? It's here. Actually, this is a perpendicular angle, a perpendicular of 90 degrees, approximately. And if I draw from this, starting from this vertex, it could be here. So what they are they a concurrent lines? Or can we say name them a concurrent lines?
Yes, miss.
What is the name?
Yes.
Okay, now so yes, they are a concurrent lines, and each concurrent lines, what does it need? It needs a point. Here, this
Yes,
point
centroid.
we call it. This point we call it ortho center of triangle. So what we name it? Ortho center of triangle. They start from the vertex and perpendicular, ending at the line, perpendicular on the line, and this point we call it orthocenter. Now, it can be on the acute triangle. It could be on the right, and it could be on the obtuse. Now, let's draw how they could be on the obtuse triangle.
Teacher, for the previous lesson, we didn't like name our concurrent lines like here in this lesson. And you miss the perpendicular bisectors when they like met all of them intersect at one point. So this either we called it the circumstances or the
Circumcenters. Yes.
Their name. But in this lesson we have orthocenter and the middle point of the median.
Centroid.
And for the median, we call it centroid. For the altitude, we call it orthocenter.
Okay.
So here, when you come back, wait a minute, let's see here. I summarized for you in the table, as you see here. Okay, these are the concurrent lines: perpendicular bisector, angle bisector, median, and altitude. The perpendicular bisector, the name of the point of concurrency is circumcenter of the triangle. Circumcenter. The angle bisector, it's in center. The median, it's centroid. And the altitude, it's orthocenter. Now, for the perpendicular bisector, it could be inside or outside. And the altitude, it could be inside or outside. So both of the perpendicular bisector and the altitude could be outside or inside a triangle. But the angle bisector and the medians, both of them are always inside the triangle. These are the difference between them.
Okay, miss.
Okay. Now let's come here. Let's draw now the acute triangle. Now, I need now to draw 3 lines, starting from the vertex, mid, perpendicular on the opposite side. And here, starting from the vertex, perpendicular on the side. And here, starting from the vertex, perpendicular on the side. These are for the acute triangle. And in the acute triangle, where's the orthocenter will be? Is it in a triangle or outside the triangle?
Inside.
So this is an acute triangle. So its point or the ortho center is inside. Now, let's draw now a perpendicular or a right triangle. Now, starting from the vertex, perpendicular on a side. So it could be, you measure it. Maybe it's here. Wait. So it's here. Okay. Now, starting from the vertex and a perpendicular side. So how it will be perpendicular? It come like this. Okay, this is perpendicular, ending at the line. And here for the right, it's starting from the vertex in perpendicular segments, ending at the opposite side. So where's my orthocenter here? It is at that point here.
Outside.
So it is, oh, okay. Or can say it is on the side of the triangle, or on the vertex, or outside, and so on. This is here for the right triangle. Now, let's draw an obtuse triangle here. I must start from the vertex and perpendicular side. So how it will be? It will be like this. It is starting from the vertex to the opposite side. Now, where's the opposite side? I will draw an extended line like this in order to stop here. And then I will start from here, stop here, and then I will start from this point. I need to be perpendicular. This is not perpendicular. This cannot be perpendicular. This will be perpendicular. Yeah. So let's extend this line here. So approximately this is my, it's not accurately correct, but as you see here, the orthocenter is it outside the triangle. This is for the obtuse triangle. So is it clear now what's the meaning of the altitude?
Yes, Miss. Miss, in the quiz you will ask us something like the accurate triangle.
No.
Oh,
We're just here to understand it.
okay, Miss.
Okay. Now, let's identify the median and the altitude. Let's now distinguish between them. Where is the median and where is the altitude? For the angle PQR, or PQS, sorry. PR, where's PR? PR, this PR. So I have this slide now. This PR here. Now they ask me now, where is PR? Is it a median or an altitude? Well, first you have to ask yourself, is it a start from the vertex? Yes, so it starts from the vertex. Now then, two things. If it is end at the midpoint, what we call it?
Median.
Median. And if it is perpendicular, what we call
Altitude.
it? Altitude. So this is here. So it started from the vertex. Yes, so it could be one of them. Now, is it end at the midpoint or perpendicular?
No, perpendicular.
So it is perpendicular, bravo. Since it is perpendicular, so it must be altitude. So PR is, since it is perpendicular on QR, so BR is an altitude of the triangle. Right. Now, look at QT. Where's the QT? This is a QT. Now, QT starts from the vertex. It's not perpendicular. But as you see here, it's told you that it's cut these two sides into two equal halves. So if it's cut it into two equal halves, so what is the name of this point?
Midpoint.
Midpoint, bravo. So if the side starting from the vertex, ending at the midpoint, what we call it? What we call this bisector?
Median.
Median, bravo. So I will say that QT is a median of the triangle PQS. Is it clear?
Yes, miss.
Yes, miss.
Yes,
Okay.
Yes.
Now here, for the triangle ABC, is each segment is a median, altitude, or neither? Let's start now with AD. AD, it's starting from the vertex, ending at a point that cut C or BC into two equal halves. So what we call this bisector?
Median.
Median, bravo. So AD, line segment AD is a median of the triangle ABC. This is for A. Now B. Look at EG.
It's neither, miss.
EG. Is it start from the vertex?
No. No.
No. So
It's
it's
neither.
not starting from the vertex. So EG is neither. It's not. It is not starting from the vertex. The last one now, which is CF. Where's C? CF. It is starting from the vertex, perpendicular on the opposite side. So what we call it?
Altitude.
Bravo. This is an altitude of the triangle A, B, and C. Is it clear?
Yes, Miss.
Yes, Miss.
Yes, Miss.
So here, let's summarize. What did we say? We said that the concurrent lines are 4 types: perpendicular bisectors, angle bisectors, or the concurrent lines in a triangle are perpendicular bisectors, angle bisectors, medians, and altitudes. The perpendicular bisector, that's the name of the point of concurrency, is a circumcenter of the triangle. But for the angle bisector, its name is an end center of the triangle. The perpendicular bisector, it could be inside or outside a triangle, but the angle bisector, it could be always it's inside the triangle. Now for the median, it's the point of concurrency. We call it centroid, and where it's located, it's always inside a triangle. And for the altitudes, it is on the orthocenter of the point. Its name is orthocenter of the triangle, and it can be inside or outside a triangle. Is it clear?
Yes, Miss. Miss, problem 3 is not with us.
Yes, Miss.
Wait, I just checked now. Just a minute.